Okay, now what we're going to do is we're just going to look at setting up some integrals. I'm not looking at actually doing the integration. I'm not going to give you a function we can actually integrate. So here's my region. It's another triangular region. I want to find the limits of integration and set up the integral over the region given. And I'm actually going to set it up in both directions. So as I look at this, what I need to do is write functions for each of the sides of the region. So in this case, this particular side is the line y equals 1. This particular side is the line x equals 2. And then to get this one, I need to find the equation of that line. So I notice I have the point 2, 5 and the point 6, 1. And so now to write the equation of the line, I need the slope. So slope is change in y over change in x. So 5 minus 1 is 4. 2 minus 6 is negative 4. Looks like the slope's negative 1. Then we'll write the equation. So y equals negative 1x plus b. And remember what we do is we plug in a point. So I'm going to plug in the point 5, 2. So if I do that, that gives me 2 equals negative 1 times 5 plus b. So b is 7. So that's the line y equals negative x plus 7. So now I can write my integral out. And so, well, like I said, we're going to do it both ways. So first, I'm going to integrate, and my function this time is just f at xy. So f at xy. Let's go dx dy first. So now my outer limits are the y limits. And remember, they have to be constants. So I look at this and I say, what's the smallest y used on that region? And the smallest y is y equals 1. What's the largest y that's used on that region? Y equals 5. Now to do the inner limits, I do x limits. And so I look left to right, and I notice the left function is the vertical line. So that's the vertical line, x equals 2. And the right side is the diagonal line. Now I can't use y equals negative x plus 7. I have to solve this so it's x equals. So if I solve this for x, notice when I do the solution this time, this is somewhat unique, but if I do it this time, I get x equals negative y plus 7. So don't forget you actually have to solve it, but that work I did in my head. So that gives me x equals negative y plus 7. So if I clean up the integral a little bit, that gives me 1 to 5, 2 to negative y plus 7, f at xy, dx dy. Now if I reverse the limits, just to show the second option, I'll be going dy dx. Outer limits are x's again, or this time. So I would look and I'd say, what's the smallest number x that uses? And that uses x equals 2. What's the largest number x that region uses? That's x equals 6. And now I do the dy's, I go bottom to top. The bottom is y equals 1. And the top is the diagonal line, and that's y equals negative x plus 7. Again, if I just neaten that up, that'll be 2 to 6, 1 to negative x plus 7, f at xy, dy dx.